discussing on file allocation methods, and I remember we discussed on types of directories. And what we said about file allocation methods, mostly they assist the users, or they assist the program to manage the memory on how we can do. To understand that most of the processes are able to So I think we can now start. And I was saying that lastly we were discussing about file allocation methods. And one of them we said it's contiguous allocation method. The file system is as a system that assists the users to manage the files, or the operating system to manage files. So in this case, there are some notes I want to share here as I teach. And if you look at a file system, it controls the execution. And it allows the execution for the processes that we have within the operating system. And I think you can see that screen. What we are saying, it is used to determine how data and programs are accessed. How will you access data? Right now, if I can use Paint here, and maybe we have some allocation somewhere here. So we say This is the allocation. And this is the first allocation, the second allocation, and the third allocation. How will you determine this is the allocation that you are supposed to allocate file? So this is now the file system that is supposed to do that. And in the most cases, we need to still look at now, this memory has already been separated in different sections. So creating of these sections is always determined by the file system. So we need to look at now the features of file system, but we need to look at the features of file system given that we have different types. One of the features that you always find within the file system is security. So let me use PowerPoint. So the first feature that you find is what you call the security. And the next feature that we find there is what you call recoverability. Recoverability. Then we can still look at the next is what you call the backing up of files. It allows backing of files. And the next one that it can still allow is efficiency. Efficiency. But not all the file systems that provide these. Then the next one, it can provide what you call naming. Remember, when you are naming a file, like now I go maybe to my desktop, maybe the desktop that I'm using, and I call this the operating system. So when I'm naming it and I call OS, whatever it's allowing me to call it is now the file system that we have. And in most cases, it works in a presentation of how we can be able to understand how are we able to allocate this file called operating system. So it is able to determine, do we have any other OS file somewhere? If we have it, automatically that file system can reject that execution. That's why we are saying it provides security, but it provides security in folder level. In folder level. Now, which is this file system that provides security in folder level? So we need to look at it. Which is that file system that provides recoverability? And still, we can maybe look at another one, which is called usability. Which is that file system? Which is that file system that can provide naming? And when you provide naming, we need to understand how and where, and then when is it supposed to be allocated. So those are the things that we need to consider when you look at various file systems. So one of the file systems that we always have is what you call the FAT file system. We have FAT. FAT means when we look at FAT, so types of file systems, types, one of them, we have FAT. FAT means file allocation table. File allocation table. Then we have NTFS, means new technology file system. Then we have NFS, which is network file system. Then the next one that we always have is HPFS, which means high performance file system. And if you look at this operating system, these types of file systems are mostly used in Windows. So all of these are used in Windows operating system. But suppose you look at now, maybe what you call the Linux operating system. You can use Exeded 2, Exeded 3, ext3. You can use BAFs, file systems, and many others that you always have within the Linux operating system. And in most cases, we always categorize them in NTFS because we understand that NTFS is a file system that is mostly used by the current operating systems that we have. It depends, because when you look at the FAT, first of all, we had two categories. One, we had FAT32, and the next one was called 16, of which we call it FAT. So FAT16, FAT32. So in this case, we need now to look at different capabilities for these file system. And that's why we are saying this FAT is an allocation table used by the operating system to locate files on a disk. Now, the keyword here is to locate. File may be divided into many sections and scattered around the disk. And I know you know what are disk allocations, where we said we have a scattered disk. And when you look at the scattered disk, now you need to see on how we can be able to allocate them. But this file system was mostly used in those operating systems. And this is the one that I'm referring it to 16, FAT16. But we always call it FAT file system. And the main features that were provided on this file system, because it was used on this operating system, it was used to create characters or to create what you call naming conventions. And naming conventions, mostly, it was able to provide naming to a file, but when it is providing naming to a file, it could not allow the file name, it could not allow the file naming to exceed 8 characters. So if you are looking at that, we are looking at the file name dot extension, or sometimes we call it the file format dot the extension. If I call it maybe my file dot doc, or my file dot PDF, So it means this is the file name and this is the file format. Meaning when you count these names, maybe I count from M characters up to C, it is not supposed to exceed 8 characters. It is not supposed to exceed 8 characters. And that's why we saw that this is not a good naming conventions, or it was not a good file system. Because if you look at now the naming where we cannot allow maximum more than 8 characters. Now, security is not good on that. Because security sometimes it can still be provided with the naming. Because when you are providing naming on a file, it is maybe we are looking at, is it easy to remember? Or maybe is it easy to cram? Or can somebody maybe interpret that name? And that's why we always provide security on files. And one way we do is what you call encryption of files. So in this case, if you look at what we are trying to interpret here, if you try to look at what we are trying to interpret here, the file naming and the conventions that are supposed to be provided on that, we find that this is not the best file system that we can have because of some issues that we have on this file system. Then we say that it can include up to 255 characters. I know that is common because now the extension of those characters, they are supposed to add up to 255. And we have one restriction where it cannot contain maybe question mark, maybe quotes, maybe double quotes, these. And that's why you find that now, if you have formatted your computer using FAT, either you are using FAT32 because they have the same features, or you are using FAT, automatically you cannot use some naming conventions. You cannot use some naming conventions. That's why you find that you try to use maybe, let me try to see whether you can have the naming with this. And we say we have OS/, can you see that? It is not allowing that because it is a convention that is mostly used within NTFS and FAT. So for these conventions are mostly not allowed in NTFS and still in this FAT. So if you look at this convention, mostly we can say we have security, and this doesn't support security in folder level, and that's why we have said we provide security into the whole of that computer, but it's not in folder level, which becomes an issue in that execution. That's why they invented the next file system that was called FAT32. And if you look at FAT32, it is an improvisation of FAT, where now we have added the capacity for this. If you look at those, it cannot allow. So here we are looking at 255 characters, but here now we can still add some character interventions. Now we are looking at MBs. So instead of characters or bytes, we are now considering megabytes to TB. Now, if you look at now to TB, at least now you can have a good way of allocating files. And that's why we find that this file system is able to provide a very big portions of execution. That's why we find that now there is this feature, partitioning size. And we are saying the partitioning size increases. And bits are used to address clusters. And I think I will not explain what are clusters. I remember I explained this in disk on input-output management. It reduces the size of each cluster. So we reduce, and when you reduce the size of these clusters, what we are saying is that if this is now the disk that you have, we can now allow it to have different sectors. So we reduce the size for each cluster. So we reduce the size of these, meaning that this size is maybe 512, because most of the disk is always given with it 512 MB, 512 MB. And that's why we can look at this file system is able to provide from 512 MB to 2 TB, because most of the allocation are provided from 512 MB. So you separate sections using 512 MB. And if you can look at most of the operating system, we have not even, we are using Windows 2000. And it is from Windows 2000 and above. Windows 2000 and above. So we are saying it is that they are offer compatibility with operating system other than 2000. So it is from 2000 and above, meaning 2000 is not included. What about the FAT? Well, we are saying the FAT allows those operating system used by Windows 2000. It is used by Windows 2000 and below. So 2000 and below, but the other one is 2000 and above. That's why we still use FAT system, FAT32 up to this current operating system. Another feature that you can add here is where it also allowed long file naming. Long file naming. And when you talk about long file naming, now we are not allowing only 8. Now we can exceed up to 11 or 22 characters in that naming. So if you look at 22 characters or 21 characters, I think when you are creating that, you cannot exceed 21. Even though we are saying let's have the maximum naming maybe to be 8 characters, we cannot even exhaust those 8 characters. So we are now advancing in naming. So this one allows long file naming, and we can still allow access speed. So access speed is high than when you look at the FAT. So that's why we are saying FAT2 provides a good file access in partition size less than 500 MB. So if it is less than 100 MB or greater than 2 GB, so it is from 2 GB that, so it provides a very high speed, and it also provides a better utilization. So that's why we say FAT and FAT32, it's just an improvisation. But through this improvisation, there were some other things that was not catered here. One of them is not security. Security is not provided to all folders. Remember, we are not providing security to folder level, and we need to provide security to folder level. We still need to increase speed. That's why we went to what you call the NTFS, New Technology File System. And that's when, because we have said fact that it's used Windows 2000 and above, this one still uses that. So that's why we can say the only characteristic that has changed here is security and naming convention. And that's why we find that now when you're providing this, we can always look at this intervention and we say it can be up to 255 character. So that is not unique because we have already provided it in the fact that too. But what it is unique here, it is when you are providing this naming. File naming can contain most characters still on this that allows that. That's why when we are using file interventions, we can still allow that. And it is not case sensitive as conventions. We can still see that. Security is provided for this rather than when you're using FAT. That's why we are saying security is provided in folder level. So in each and every folder, you have your own security. So if I go to this folder that I'm having here, I can have my own security. So for this case, I have my own security. If I go to properties, maybe you provide security for this, you have provided security in the whole system. Which are these security provided? One, we have full control. We can have modify, we allow. So these are one. So we can maybe look at whatever we can maybe deny on that. So we allow systems, we allow administration, we allow any intervention. Maybe if you don't want this file to be accessed on a desktop, maybe we can try to remove. Maybe we can view the controls that are there. Maybe if I want to remove them, I can be able to remove the way I want. Maybe show the advance. So these are the rights that are given to this file. One, we full control, traverse folder, list folder, read attribute. So you can list, we can read extended attribute, create files, create folders, write attributes, write. All these are securities that are provided on these folder that you have. So that's why we are saying when you're using NTFS, you provide security in folder level. And that's why we are saying provide file and folder security. Files and folders are safer than FAT. Security is maintained by assigning NTFS permissions, and those are the permissions that I have already shown you to file and folder. Security is maintained at the local level and the network level. So one advantage is that it provides access of files in network level. And when you provide in network level, what we are trying to introduce here is another file that we call NFS, Network File System. And the network file system, they interchangeably change. It's like when I use my file, you're using a Linux operating system. So in my Windows, I'm using NTFS. When I go to Linux, automatically it changes to another file system, which is now XLR3 or XLR4. So we don't have a limit, or we don't have a limitation of file access. So that is why we say NTFS provide a clear security that allows you maybe to access files in the network. So that's why we are saying NTFS partitions has an access control list. So you have all the controls that you can have. You have privileges given. And the privileges given, I think you have seen those privileges given on this file. Maybe if you look at now properties, you can have some attribute privileges given. If you go to advanced, you can see allow files in this folder to have content index in addition to file partitions. Maybe we can allow compression. Maybe you can allow encryption. If you allow encryption, and maybe we say that change to this folder, apply changes for this folder only. Maybe we can allow that. And when you see that, it says backup your file encryption key. This helps you to avoid permanent losing of content. So that is the case where we are saying it allows encryption of any manner. I have not extended to encrypting that file, but it allows encryption of any file manner that you have. Then the next one is partition size. Now we can reduce those sizes completely, and that's why we say file size are much bigger than the fact portion and files. The maximum size of the NTFS can be 16 exabyte. 16 exabyte. So we are trying to increase the number of partitions, and these partitions are the ones that I was looking at this point, where maybe I was using Paint, and I was saying if you are using these partitions, and we now look at these sections that we have, now we can increase many. It's not like the one that we were using previously. Remember, we are not increasing the size. Now we can increase up to 4 GB to 64 GB. 4 GB to 64 GB. So in this case, we can try to look at the interpretation that files are now accessible in various sections. Files are now accessible in various sections in a network. We can allow more expandability, and that's why we are saying it can still provide compression. And I think you have seen somewhere I have already created, maybe we can try to create some compression of these files. It allows that. So if I try to compress this, it can allow this. Maybe I can compress using this, and maybe I compress. And if you look at this, you can see this one has been compressed. So this this file system that you always provide here, it allows you to do that. It allows you to compress these files. And compression, I think it's not new to you, because we say we are reducing the size of a file. We're reducing the size of a file. So in this case, up to now, maybe we can be able to understand the difference between these file systems that we have. Am I okay? Is it easier for you to differentiate those three file systems that we have talked about?
Yes.
Okay. Donald, are we okay? Are you okay? So I'm talking to Donald Nzioka. Can I continue? Okay.
I think yes. Muted this microphone.
Oh, just unmute your microphone, please. When you are talking, unmute your microphone. Yes, now you can talk. Are you okay?
Yes, I'm okay.
Okay, so we can continue.
Yeah.
And the next one that you are supposed to discuss is, so before we even terminate on NTFS, so we have seen that there are some things that has been added here. One is a security. The next one that has been added is the partition size. You can add partition size. The next one that we have added is compression, file compression. You can allow compression. You can allow compression. And then reliability. So if files are not provided with reliability, now that becomes an issue. So are we reliable? Is this file reliable? When you talk about recoverability of file, is it recoverable? Now, when I want to recover file, I can recover. Now, that is reliable. So it is more reliable in a way that we can use that file that we are using. The next one, it can allow cluster mapping of files. And when you talk about cluster mapping, we are saying it is able now to provide different sectors. And when you look at different sectors that you talked about, is when you are providing now those circles that we were having, tracks, then you divide them to sectors. So I think up to now, we have seen now the NTFS is better because it allows us to use files in network. It allows increase of the size. It allows file compression. It allows reliability, and it allows cluster mapping. And if you can remember, what we said about mapping of files. We said in hardware, we must map files. And when we are mapping files, we always need to use what you call the disk controller. So the disk controller is the one that is now managing those files, either by defaults, the clusters that are supposed to be removed. So it always allows that. So NTFS, NFS, Network File System, it's just an improvisation or an addition of NFS, because you have said NFS can be used in network. So when you go to network, it converts directly to NFS. And that's why we are saying it's a client server application that lets a computer user view an option or store and update files on a remote computer. So that's why when you're using file, you can update files on a network. And it uses some protocols, and these protocols are mostly distributed. Maybe you can use SMTP protocol. It allows FTP protocol, that is file transfer protocol. So I can write them here. SMTP, this is what you call the simple mail transfer protocol. So protocols are rules. Like now, those rules that you observe doing your cron jobs. We have FTP, file transfer protocol, and then we can have telnets. So this is a protocol that allows users to use files in a remote. Allows user to use files in a remote. This is one that allows you to transfer files, either you're using a mail. This allows you to transfer, this allows you to receive the files, even though you are accessing them over the network. So that's why we are saying the NFS protocol is one of the several distributed file systems run for network attached storage. We have the network attached storage that we can use. And when you use the network attached storage, what we consider here, we are considering the resources that are required in a network file systems. So what are those resources that you require in a network file system? And it also allows the user or system administrator to mount all the portions of the files on a server. So the moment you now access a file on a network, first of all, you have to access the server. But how will you access the file on a server? So the way we access file on a server is mounted by what you call the NFS, which now allows you to do what you call remote procedure call. And I remember there is a point where we were talking about remote procedure call. And what we said about remote procedure call is where we say we can have a sender, and here we can have a receiver. So when a sender is sending and a receiver is sending, so there is that sending and there is that receiving. So this one is sending. So for this one, when this is said and this is now you are receiving on that, this person is waiting. So you wait. So when this person is sending now, this person still wait here. So there is send and wait signal, send and wait signal. And these send and wait signals are the ones that are now catered by this one that we are calling NFS. So, so what we can say is that it is allowing what you call remote procedure call to route requests between clients and server. So the moment you are requesting a file from a server, that is provided by NFS. And if you look at that, it was developed in 1980 by the Sun Microsystems, and that is not relevant to that. And we have another network. We have another protocol that is called user datagram protocol. User datagram protocol, and I think you'll be able to understand this. If you are doing diploma for now, there is module 3 that you'll be dealing with what you call data communication. and you'll be able to understand user datagram protocol is mostly used to allow transport of files from one point to another. And that's why I always like maybe giving maybe the section that you always have within the network. And I can represent that all people seem to network data physically. All people seem to network data, so physical. So we have physically. So this is application. This is presentation. This is session. In a network, that is in a network session. This is transport. Now, when I'm talking about datagram UDP is now here in a transport because we are transporting files. This is network, and this is data. This is data. All people seem to network data physically. So we have data. So in this case, we can say we are transporting files using what you call user datagram. So that's why we always say that this is data link, because we are linking. This is data link because we are linking files. We are linking files to the physical device. And the physical device is maybe a computer, your phone that you are using, or any other device that you can use at a given time. So that's why we are saying running over IP network to provide stateless network connection between clients. When you look at stateless, we are meaning connectionless. So we are using maybe Wi-Fi connection, so it can move in like now, I'm maybe using Google, but it is not, I'm not connected to the server for that Google. I'm connected with what you call stateless, connectionless. So there is no cables that are used within that. So if you can look at this, the advantage for NFS is just to provide communication over the network. And we are providing communication over the network through the use of what we are calling servers or protocols. So we use protocols so that we can communicate with servers in that. So in this case, we have already now reduced the task force that are now in FAT and FAT-2. Now we have already allowed files to be accessed in a network. The next one, maybe that we can be able to discuss here, is what you call the HPFS. HPFS is just an improvisation of these two file systems, NTFS and NFS, where we are saying it was first introduced with OS2. And if you can remember, OS2 was the first operating system that was invented after DOS to allow for greater access to large hard drives that were then appearing on the market. It was also necessary for a new file system to extend the naming system. So we are now extending the naming system within the organization. We are now providing more features which were not provided in FAT, which were not provided in NTFS, etc. So we are saying it maintains a directory organization of FAT, but adds automatic sorting. Now you can see here, even though it is now providing that search on FAT, it is now still providing sorting, arranging of ascending and descending order. It now extends the file. File names are extended up to 254 double byte character, double byte. The other one was single byte character. Here we have added features that were on FAT. So we can say high performance file systems is mostly improvising the FAT system. It is improvising the FAT system. And it always allows file to be composed of data and special attributes. So if you can look at the files that we always use nowadays, we can use those files and we provide special attributes, or we can now increase flexibility on these files. So we are still using FAT or FAT that we are using FAT and FAT that 2, but FAT that 2 has been improvised with features by HPFS, depending on the operating system that you are using, depending on the operating system. So that's why we find that now the other one was able to hold MBs, NTFS, it was able to hold MBs, but this one is holding bytes. We are still in a quagmire for this. And that's why we find that HPFS is just an added features on each and every operating system, on each file system that we have. So we add features on that. And what we can say is that most of the file system, the best operating system, the file system that we can use is what you call the NTFS, because we are providing security, we are providing network, providing recoverability, we are providing backup, and we are providing even sorting of files, because we have said HPFS is embedded within the FAT, so it is embedded within these applications, and it improvises that way of execution. So I think maybe we can be able to understand that file systems are able to always allow more executions of these processes that we have. They are able to allow files to be accessed remotely. They are able to allow files to be accessed in various platforms. Either we are using Linux operating system, either you are using Ubuntu, either you are using Red Hat, either you are using Fedora, we can still use different file systems. So whatever changes is the file type, which now when you go to mobile phone, it uses RAW. When you come to computers, it uses maybe NTFS or FAT. And that's why we can say we need to now to understand further on what you call the NTFS structure. And when you understand the NTFS structure, we always understand that we can create some section of NTFS. Here we have what you call the file partitions. Maybe allow me to use another, maybe allow me to use these. I insert a table here, and maybe I can insert a table with let me try to have these. Let me create. So in this case, the first one we have the partitions. We have the master boot table. We can say master boot table. Then we have the file system. Then we have the file area. The file area. So I want to remove this. I want to delete this. Can it allow me to delete? Yes. Delete that column. So this is the section that I have on NTFS. On NTFS. So this one we are looking at. Maybe I can I? Maybe let me copy. Then I move to the next slide. So let me see. Maybe I copy that. Okay, the issue is I want to move it. Maybe I can move it to, let me see whether it can work like that. I can use snipping tool because of that issue. that is the one that I'm talking about. So we have partitions, and we have the master boot, we have the file system, and we have the file area. So in this case, if you look at the file partitions, we are looking at how can I create those sections. So this is what you call the file structure. The file structure of NTFS, or the structure of NTFS. So in this case, we are looking at the partitions. How will I now try to create these sections? So that part allows you to create sections in each and every memory that you are having or the disk that you are having. But now you must have what you call the master boot. And the moment you are having the master boot, we are now having the table, and we are seeing this is 1, this is 2, this is 3, this is 4, and this is 5. So in this case, we can say in 1, we are having the section or the size. Maybe we can have partition, then we have the size. So we say this one I'm having a size of 200. If I go to the next one, I'm having a size of something. So in this case, we can say this master boot is the one that provides, the allocation table for each and every section of a disk. Then the NTFS, the file system, is the one that is now providing security, recoverability, the organization of the files that we are supposed to have. So in this case, we can say the file system is able to provide the better or the best approach to allocate files in a given disk. That's why we have the file area. This is where we are allocating files. So this question is common. I'll post those notes. I have posted a note for file systems, but I'll post these notes for the structure of file system. You read it, the operations, the functions of each and every section, because we have 4 sections. Partitions, it is able to allow, or it allows allocation of the files. Master boot, it allows you to manage which file is supposed to be allocated, where and how it's supposed to be allocated. File system is able to provide security, and file area is now the file that you are allocating on those sections that we have within the operating system. So up to now, maybe I can maybe receive some questions from you. I can receive questions from you. So questions? So maybe I'm waiting for a challenge, please. Or can we proceed? So I'm waiting for any challenge, please. Ruton, yes?
Can NTFS be also used in Android?
Yes. So here I'm generalizing. I'm not specifically using it either in Linux operating system, but what we have said there is that if you use NTFS, it can be used in Android. It can be used in Android. So Android, Windows, they work together. They work together. So most of the file systems that we have in Windows and those that we have in Android, they are the same. But now the changes comes when you are talking about Linux operating system. When you're saying Linux operating system uses extended 3 or extended 2, now that extended 3 or extended 2 is converted to NTFS in Windows. But for Android, you can use NTFS. Is it okay now?
Yes, I'm okay.
Okay. Michelle, do you have any question? Michelle, do you have any question? I'm waiting for a question from Michelle. Then in Donald?
No.
Okay, so we can proceed. So what I wanted us to do, I wanted us to go back to the portal, and then there are some questions that I have posted there, the quiz. Please, can you make sure that you do them? Because now we are sending marks. We are sending marks to NEC. And these marks will assist you to grade up your grading system. So please, can you make sure that you do those quizzes that I have sent? Then I will create a chat room, and then I can use the wiki so that the moment now we complete with those cards, with those quizzes that I have already posted, we can now start. We can now start chatting. We can now start chatting. Are we okay with that, Zioka? Are you okay with that?
Yes.
Yes, please, we do that question. Then after that, maybe we can try to create a chat room. I will still post wikis, and for wikis, I will post a challenging questions that has an answer. Then maybe we can challenge it, whether it is correct or wrong. Right, maybe we can add. It's like now we are using a Wikipedia. And when you're using Wikipedia, you write something, then you can update that. You can update. So please let us meet in the quiz session. Are we together? Ruto, yes. Can we meet in the session?
Okay.
Michelle, I have not gotten any communication from you. Michelle, I have not gotten any communication from you. Michelle, no communication.
Yes.
Okay, sir. We can meet in the quiz room so that we can answer those quizzes. And let's meet. Yeah? Yes?
And what about the NSEM exams?
Then, the NSEM exam.
Yes.
So what we are supposed to do, we'll do your NSEM exam using the same portal. And I think you have downloaded an application, Safe Exam Browser. Have you downloaded that application? I think it was sent to you. Have you downloaded?
No.
It is supposed to be embedded in your systems because we'll be using that platform, the SEB platform, SEB client platform. And the SEB platform is the only one that will be allowed for examining because of screening. So if somebody maybe is trying to copy the exam, I can see you copy. Are we together? So yes. Please download the SEB. I think if you go to, let me maybe try to go back to the system. Maybe I tell you whether it is presented to you. Because I know it has been sent to news. So when you go to news and announcement, you you'll be able to see it, because I can see there is a student guide for online examination. So please make sure that you read that. And this guide has already been given on how we can be able to maybe to do the exam. And I think this is the guide I'm presenting to you. So make sure that you read it. And if I can see that there is download, unzip, and install the Save Exam browser, then open .ceb file. .ceb file. When you open that, I think it has been given to you. So when you go to announcement, you'll be able to see all these steps that you are supposed to follow. And when you follow those steps, you'll be able to. Okay. Let me share the screen. Sorry, I'm sorry for that. So what I'm saying is, let me try to share that. So what I'm saying is, there is when you go to announcement, news and announcement. When you go to news and announcement on your portal, now you'll be able to see these guidelines that has been sent to you. And the guidelines that has been sent, just go and download one of them. I have downloaded one. And maybe we can say there is a presentation that I have downloaded. And the student guide online examination, what you are supposed to have in your exam for you to access, you're supposed to download the Save Exam browser. It is in your portal. So you download, you unzip, and then you install in the computer or the mobile phone that you'll be using. Don't download and install in a computer that you'll not be using. Download it in a computer that you'll be using. Then you use .ceb file. You'll be able to use .ceb file. Everything has been provided. The access key is ZTEC123. And for this case, we have login and exam access. So all the steps has been provided for you. So CEB grant, we will be clicking this. I don't know. To me, I have not updated that. So the moment I update, maybe we can have a session that I can maybe show you. Maybe CEB. So CEB. I've not configured this. I've not configured this. So when you configure that, you'll be able to follow those steps. So you'll be using that application. So the moment you click on this, it opens the portal. It opens the portal. And when it opens the portal, now you can be able to access your portal and be able to do the exam. So please read that. Please read that. And when you read that, you'll be able to understand what we are saying. Is that clear, please? Is that clear? Michelle, is it clear? Ruto, is it clear?
Yes.
Yes, so please go and download that application, because you'll not be around to do the exam if you have not downloaded that. It's good for access. So let us meet in the quiz room so that we can answer those quizzes. Okay, thank you on that.